welcome to this super evening in London, at least. I hope it's really good where you are too. And to our next enthralling, gripping, fantastic, fascinating talk, which is tonight. We are BCS London, BCS London North, BCS London Central, BCS London South branches. I have the great fortune to be the chairman of those three groups with a super set of committee colleagues. But I have a general question for you before we start. How are we doing? What are you doing? What are you doing? What are you doing? Because I think you will resonate with me when I say that we in IT and our privileged positions in this position are trying to do something. We're certainly part of something. Hopefully we're participating actively. This gives you a clue. Let's shape the future together, because IT is an integral part of so much of our lives today. I don't just mean business lives. I mean also our social lives, our environmental lives, and you can extend that list as you wish. Undoubtedly, some people will say our ethical lives. There are all of those things as well. But what we're aiming for in general is to help the world and the next generations, our children, as well as our friends, as well as ourselves, get through the next few years. Oh, that sounds ever so dramatic, doesn't it? But what I mean is organizations as exalted as the United Nations, the World Economic Fund, etc., have published a series of targets and goals. They call it the Sustainable Development Goals, and they include things like AI, blockchain, IoT, big data, advanced materials, robotics, AR and VR. We've already leapt past there to call it the metaverse, haven't we? 3D printing, and we're already printing houses, drones. If you look at a certain frontier towards the east of Europe, you will see how drone technology is advancing rather faster than perhaps we would wish. 5G, synthetic biology, oh my God, yeah, cloud, internet access, quantum, and others. In our London branches, what we're trying to do is to expand our knowledge, your knowledge in those areas, and to provoke questions, because maybe we run something which is too simplistic for you. Great, ask the questions, offer your services to speak. Let's move our knowledge forward. So we're doing all of those, and we have a number of initiatives. Yesterday, we were very fortunate to have a panel of people, some of whom are actually here today, and they were talking about a subject which certainly is all sixes and sevens to me. Sorry, did I say sixes and sevens? I meant ones and zeros and ones and zeros and ones and, or maybe not, quantum computing. And we're running a whole series of talks to enlighten ourselves and expand our knowledge about that. Another one is AI. We will have a talk on May the 31st about AI, just some aspects, because already that topic area has just exploded, hasn't it? So whenever I say AI, before people used to say, machine learning. But now when I say AI, people say ChatGPT. Or if they're really up to date, I suppose, GPT-4 or something that I have little knowledge about, but that's just one stream of AI. And that's how our world is going. So if you say, well, how is this particular field expanding? I would say to you, which particular field, and how is it integrated with all the others? Well, tonight, we're very fortunate to have a great speaker from IBM who works at Hursley near Winchester, the IBM research labs there. So you probably get an inkling about her deep technical knowledge. And she is going to tell us more about what? About cloud. And you might have seen our 3 webinars that we had already with the IBM expert on cloud, who is now the CEO of BCS. He's called Rashik Palmer, and he's very much a supporter of ours, and also of our next speaker, who I'm going to ask to tell us much more about yourself, please, Emily Jiang.
Oh, thank you. Thank you. Hello, good evening, everybody, and all the people online as well. I'm Emily Jiang. I work for IBM. I worked for IBM for over 16 years. It's based at IBM Hursley. Anybody have heard of Hursley Lab? Hursley Lab? Oh, you have. Yeah, it's a very pretty. If you come across there, I invite you to have a tour there. Really nice. I'm a pretty technical. Actually, I'm specialized in Java, so I'm also Java champion. Any of you know about Java? Wow, here you go. Yeah, this is great because in tonight's talk, I talk about cloud native applications. And obviously the concept applicable to all sorts of different languages, but I have some special like information about Java as well. Let's get started. By the way, I'm also I'm a quite new fellow. I got gained my fellowship at BCS recently, so that's why I'm really passionate to come here to give a talk. This is my first talk at BCS. Okay, so I talk about so it's a hybrid cloud, and then talk about microservices. Any of you know about microservices? Okay, a few, great. And talk about the myths and facts about microservices, and also talk about deployment, and also the future of the hybrid cloud applications. It's I think now, no matter where you work, you hear the cloud being mentioned pretty much every day, right? And the future is a hybrid cloud. So hybrid cloud, what is the hybrid cloud? You met sometimes people talk about multi-cloud, and also sometimes talk about hybrid cloud. For hybrid cloud, basically is a private cloud and public cloud. So this is very common because some applications, because high security, also the some special policy requirement. So you do not want to put the application in the public cloud. You want to store in the private cloud, but you want that application also interact with the application in the public cloud. So basically, you are some base in the private cloud, some base in the public cloud. So so this is one operation might go through the whole private cloud and public cloud. So this is a hybrid cloud. For multi-cloud, so you could have like a Google Cloud, could have an IBM Cloud, and also have like AWS. For that, I heard some companies, so they use a different cloud because the price issues and etc. And they use this is basically it's that's called a multi-cloud. So multi-cloud is pretty much like they are in parallel, not involved in single transactions. So this is a hybrid cloud. Obviously, what do you need the cloud for? You want to deploy something in the cloud, right? You don't really want to get a cloud and doing nothing. So you want to serve some services, put the services on the cloud. So these services basically implemented by applications. So this is what we are focused on, is hybrid cloud applications. So what sorts of applications are suitable and adaptable to be deployed to the hybrid cloud? So that's kind of now the common theme is microservices. Basically, it's the microservices is a target in the hybrid cloud. Although I asked about microservice, some of you have heard of microservices. Any of you are using microservices right now? Okay, no? Okay, one of you. How many do you write microservice, deploy microservice?
Both, yeah. Both.
Okay, great. So which language?
Java.
Okay, awesome. All of you should follow your path. But let's step back, and hopefully in tonight's presentation, you will learn the whole history about microservices. So it's, in the beginning, it's back in 1997, IBM released the technology called EJB, Enterprise Java Beans. Any of you heard of it? Okay, so however, it's really hasn't got a big haven't got a good feeling associated with it, right? It's the first, basically, it's the concept was good. Basically, it's saying, okay, this is reusable component. However, it was really, really complicated. When I first came to IBM, that's kind of the 2016, I think. I went to a course, like a 1 week course, to learn about EJB. And then after that, I still didn't get EJB. And then previously I thought, okay, I thought I was really smart because I did really well in the universities, etc. But after the course, I still didn't understand much about EJB. So, however, I was not alone. Afterwards, I found out. So that's why it's this is very complicated, and people just eventually basically want to go with it. The other thing is because EJB is the only solution for Java. It does not work with .NET, doesn't work with C++ and others. So this is kind of the and then afterwards, we really want to come up with something the language agnostic, not specialized in Java or some other language. So it came up with SOA. Any of you heard of it? Yeah. Service-oriented architecture, SOA, is the other. It's basically the concept is quite good. This is created in around 1999. So it's basically the design some component. This component can be written in all sorts of different languages, could be Java, C++, or C, but they can communicate with each other using a protocol called SOAP. Have you heard of SOAP? Yeah, it's also quite complicated. It's all, even though the name is called simple object access protocol, but it's not simple. And also the message sending over between the services is in XML format. So it's but a transport using HTTP, which was great because HTTP can bypass firewalls and etc. So because it goes through the SOAP, using the SOAP. SOAP was released by Microsoft, I think it's 1999. SOAP, and also even though you say hello, you have to convert into XML. So it's basically the few letters, 5 letters, and then you come up with an envelope and with all sorts of ceremony things. It's basically gradually people didn't want to use this SOAP technology anymore. And then in around 2007 period, that came up with another technology called REST. Have you all heard of REST? Yeah, so this is great. REST basically representational state transfer. So for REST, basically you can do get and put and also delete and etc. So it's basically access all the database and dealing with this all the database. So this is a REST. Basically, the services using the REST, they were given a new name called microservices. So this is the kind of basically the history from EJB and evolved into SOA and eventually become microservices. So that's around the 2010 period time. And then once we have like the new concept for microservices,
I'm so sorry to interrupt, but we're gonna have to evacuate.
oh,
So.
this is my first time talk and also first.
Well, you're on fire, that's what it means.
Fire alarms going off. Yeah, okay. Sorry about that, people online, and we were evacuated. Luckily, it was a false alarm. Was positive. Anyway, let's resume. It's have you all heard of monoliths?
No.
Monoliths. So if you are not doing microservices, your application is a monolith. Yeah, when you go back like tomorrow, actually your application is a monolith. Now I'm asking, is monolith old-fashioned, problematic? Is that evil? Yeah, do you think your application is problematic? Or do you think you need to modernize it? But let's find out later. Let's first understand what is microservices. So this is microservices. Microservices actually is kind of the maintainable and testable. They are independent. The big fact is the kind of independent. So when you like release one microservice, you do not need to coordinate with others. Now you are doing monoliths. When you do a release, you have to like talk to other team, right? You change the API, affect your the other department. So you won't be able to like release your application unless they say, oh yeah, it's okay, I tested, it's okay, go ahead. So for microservices, basically it's managed by a single small team, like 4 or 5 people. If you have a bigger size team, manage one microservice, that's not going to sell. And also it's the kind of the one microservice, you need to use one sentence to describe what it does. Yeah, okay, this is the kind of it's basically sales stuff. That one is basically taking payment, right? You need to have a capability. Okay, some myth about microservice is some people like asking me, is kind of the smaller the better? Is how many class? You know, is most of you are doing Java, right? Is how many classes should I have in one microservice, or even C++? How many classes? Actually, its size does not matter. It's the other thing is I talked with some other company. They came up to me is saying, oh, I have like my company have like 10 microservices. Is that enough? Okay, I do not know. So it depends. Like it's not like the more the merrier. So it's basically your microservice should have the right capability and no fire alarm, right? They interact with each other in a nicely fashion. And the other thing, your org should have the similar structure with the microservices. So you have to change the culture in order to fit with your microservice arrangement. So actually, is the other myth, is microservice is the final destination. Now you are doing monoliths. Do you think in 5 years time, you must migrate your application to microservices? Do you really think one day your application will move to microservices? Maybe, but may not. So that's again, it depends. Actually, I ran a survey last year. Is a lot of companies are pretty happy with your microservices. So you don't need to panic. You don't need to migrate your monolith application to microservices for no apparent reason. The only reason you want to migrate is you want to scale part of your application. In that way, you have to think about how to speed that part out of your monolith. Okay, the third one. The third one is kind of the people think a microservice is if something not going well, and then the developer will say, oh, because we are not doing microservices. If we do microservices, our job will be much easier. Now it's if you manage development and deployment, it's okay. Once we do microservices, I don't need to do this deployment. Who will do it? You have to do it yourself. So the tasks are not lessened. It's still there. And the other thing is people thinking microservice increase productivity. Do you think you can move faster if you do microservices? That's not going to happen. If you do it badly, you've got a distributed monolith architecture. You are even moving slower. And the other thing is, if you have a performance issue, and you think, oh, let's chop that up to do microservices, it will be faster. No, it's not going to help. It's add up probably even slower. So you have to look at how to speed up your application. And basically you need to look at the problem. So microservices is not a default answer for the problems. Actually, there was a QCon talk in 2020. So I was there before the COVID. This is what the last conference before the COVID 2020. One company is talking about they went from monoliths to microservices. Eventually, they found out their productivity dropped. Basically, they moved even slower, and then eventually they merged all microservices back again into a monolith. So this is one segment went back to monolith. So there's I put a link here. Is their articles, you can take a look. So some truths about microservices. Microservices is the kind of these top 3 things. Independent deployment. So basically, is you can one single team, you write the code and deploy the code, maintain the code. So you do not need to talk with the other teams. And then also is you need to have a CI/CD pipeline. So basically, is you do continuously development, continuously deployment. So basically you have set up your Jenkins pipeline and automatically push. Any of you use GitHub? GitHub? Oh, that's great. Jenkins? So you should be fine. So you should have the CI/CD pipeline set up for the deployment. And then the third thing is architecture and also the culture change. So if you have a bigger team, 10 or 12 people, and if you do microservices, you have better split it up team into smaller teams, so they can manage microservices. So the other thing is this is the often question I was asked at the conference, and people ask, oh, I share a lot of classes. How can I share this code in microservices? In microservices, no code sharing. It basically is so people say, oh, I have to duplicate the code. Yes, You duplicate code. Once you do code sharing, you're no longer independent. So that's why. The other thing is also you do not share database. One microservice just manage access one database. So basically, it's that you different microservice do not like trying to manipulate the same database. So you have to organize your data in order to go with microservices. If you couldn't split up your data, in that case, that's no go for your microservices. That will create a headache for the transactions. And eventually you create a distributed monolith. And then the third one is language agnostic. You can use Java, you can use Go, Python. Any of you know Go? No Go? Okay, a little bit. And Python. Okay, but a few of you. And yeah, C#. Looks like a Java is still majority here, right? So which is great. Okay, so what kind of things you should know if you do decide to go with a microservice? So one thing is you need to know microservice is not a default answer for your problems. If you have a performance problem, you need to sort it out before you go with microservices. Otherwise, you take that problem with you. If you do decide to do microservices, and you need a really good architecture. It's not like, okay, I draw a plan here, I'm going to do microservices. So you need a kind of the pattern. So you can either adopt domain-driven design or event-driven design, or not ready-made driven design. I know it's kind of nowadays, if you search for jobs, if you put a microservices there, and there's a lot of jobs popped up, right? And then people say, "Oh, let's do microservices so I can get a better job." But that's not the way you should go with microservices. So it's I think the domain-driven design or event-driven design. The other very super important is data operation. If you do microservice, you have quite a few microservices. You have to monitor them. So basically, create some if something goes wrong, you need to have the tools to figure out what's wrong. The other thing is kind of I already mentioned is kind of you need to have a corresponding team culture. So it's a smaller team, and then it's kind of the one single team manages this microservice from development to the monitoring. So it's, you don't have one tester, one developer. You do everything yourself. If you do decide to refactor your monoliths into microservices, you need to be careful with it. And it's not easy to directly transform your monoliths into microservices. There's some patterns like a strangler pattern. And also IBM has used AI to directly chop monoliths into microservice. It's called a mono to macro. You could Google it and find out how you use AI to basically refactor monoliths into microservices. Basically, it directly monitor your data, the data, the transformation from one, for example, one class to the other. Eventually, it's find out the boundary, and then it's kind of gradually chop the bigger piece into smaller pieces. So this is domain-driven design. So for domain-driven design, so basically it's when you design like a microservice, you need to draw the boundary. It's called bounded context. And then it's like this is to be like one unit. This is another unit. So this is one microservice. That's a different microservice. So basically you need to work out your operation and find out how many microservices you need. Where is the boundary? This is domain-driven design. Domain-driven design is also quite complex. there's a lot of books, however, not many people can use domain-driven design to do it perfectly. Domain-driven design can be accompanied by the event-driven design. So this is the kind of this design. So use a message broker like Kafka or MQ. So they interact via messages and then is access the database. So this is the event-driven design. But the fact is, no matter the company will go with the microservices, but eventually that will still hybrid. You will have a monolith, you will have microservices. So they will coexist. So there's I think it's very rare one company will directly use everything microservices. There's if you have an application, you do not need, if it hasn't got a problem, you do not need to rush to kind of convert to be microservices. Actually, let's go back to the topic I mentioned earlier, hybrid cloud. Eventually, you don't really worry about monoliths or microservice. All you need is cloud native applications. Basically, you can deploy this application to the hybrid cloud. So what is the cloud native application? It could be monoliths or could be like a microservices. So this is the kind of this characteristic. The first one is a scale. So in the cloud hybrid cloud applications, if it's under high demand, you should have automatically duplicate a few, right? So this is the kind of it should be restful. It's basically it should be like a kettle. So and then if something is not under load, is quiet, is also shrink. So it's a kind of it behave like a kettle, not a pet. And the other things that should be configurable. Is all the configuration should be outside your application. So you can configure in the cloud, in the Kubernetes, and etc. So in this case, you do not need to, if you want to change the configuration, you do not need to redeploy your application. And then third one should be fault tolerant, should be resilience. Is no matter what, your application should work. Even it's a few years ago, I don't know whether you noticed this. When you were trying to check your backup balance during night, and then you got an error message saying, "Oh, sorry, it's under maintenance." Have you ever heard? Yeah. Do you notice that nowadays? Do you see that anymore? You know what happened? Because it's still doing maintenance, right? Why is it nowadays you don't see that? So that is a more resilience. So actually, when you check your balance, do you really want to see that to that moment of time, how much your balance is? When it does the online processing and etc. If it's the bank took a snapshot, right? And then it goes through the kind of the transactions doing reconcile all the database. And then when you access your account, you still can see the kind of the pretty much right to the point of that night and the transactions, right? So it's in that case, you still can access all of the history back to the point a bank is doing the transactions. So because it's more and more the application is resilience, the fault tolerance. And the next one is the application should be discoverable. If you deploy a microservice like a weather company, they have some applications. And when you write an application, you can discover their application, right? You can use it and call the application. And also the application must be secured. Microservice and cloud native application must have a way to secure. Is the kind of prevent from any unauthorized access. And then this is very important, traceable and monitorable. If you have monoliths, probably you only have 1 or 2 applications. If you have microservice, probably you have 10, 20 microservices. If something goes wrong, if you don't have a trace, you will have greater difficulties to work out where is the problem. That's why the trace and the monitoring is very important. For monitoring, which is different from trace. For monitoring, if like something is going to go wrong, you got a warning. Like this fire alarm is kind of basically monitoring something, right? It's find out the factor is reach to the security out of security range, and will give you kind of the warning. So we have to evacuate. So the monitoring here is we say, oh, your application is going to die. At that time, before crash, you can take some precaution of it. So this is the monitoring. So finally, cloud native application is very smart. It should be able to talk to the cloud kind of infrastructure, like a Kubernetes. It can say if it's going to die, it will tell Kubernetes, sorry, I don't feel well. Kubernetes will automatically kill this one and then start a new one. So this is kind of some characteristics about cloud native applications. You may think, okay, gosh, it's so much to worry about. Can I get any help? The good news is if you are doing Java, it's most of you. So there's a good APIs, cloud native APIs provide to you. Is like top ones, Macro Profile and Jakarta EE. Any of you have heard of it? Macro Profile? Okay, no? Jakarta EE? Okay, you have Java EE. Java EE? Or you have Jakarta EE is a successor of Java EE. So Java EE basically originally was created by Sun, right? Yeah. And then when Sun was bought for Oracle, it moved to Oracle. And then eventually Oracle didn't want to invest too much on Java EE and then donated to Eclipse Foundation. And then it's renamed to be Jakarta EE because of the branding and also the IP issue. It's called Jakarta EE. So if you have not heard of it, check it out. Eventually, I have some references link. So these offer a lot of APIs for you. And then there's a runtime support Macro Profile Jakarta EE. So the first one, Open Liberty, that's IBM open source product. Have you heard of IBM WebSphere? Yeah, IBM WebSphere. So Liberty is the new generation of the WebSphere. So Liberty is a shining open source one, trying to replace IBM WebSphere. So this is check it out, and there's some other technologies as well. So this is Jakarta EE. So this is a lot specifications. If you do a database, it's called JPA. Any of you use a servlet? Servlet, or you have? So it's servlet and also Jakarta Faces. And then this one, Jakarta REST. So this is allow you to create a REST services. And also you can use the JSON format for the transformation. So the cloud native applications, so this is the kind of 3 pillar. So you can use the micro profile config to configure the service. You use the REST, CDI, JSON-P to create a microservice. You use the REST client to connect these cloud native applications. And have you heard of GraphQL? Yeah. So this is for so GraphQL trying to fix the performance issue with the REST and the fetching over fetching. And if you do the kind of the messaging, any of you heard of Kafka? Kafka, okay, a few. So you can use the reactive messaging directly to an incoming, outgoing, and interact with Kafka or some other message brokers. And also Open API. Any of you use Swagger? Swagger? So this is Microsoft Open API is a very simplified Swagger. And the Microsoft for tolerance to create a resilient microservices. And this is GWT, so secure microservices. On the top, telemetry health metrics, directly observability. Have you heard of the open telemetry? If you haven't, check it out. Open telemetry is going to the future of the observability. Is language agnostic. It has Java or these APIs, and also have .NET, and also have Python, all sorts of different things. So it's a microprofile. We have a microprofile telemetry. So this is a bigger pillar for you to, if you are not doing like microservices, cloud native applications, check it out. This is a lot of APIs for you to very simplified for you to create cloud native applications. Okay, I talk about cloud native applications because once you create a cloud native applications, it can work really natively in the cloud. It can be private, public, and also hybrid. So it's both. This so it's basically in the past I talk about application development, but what about the deployment? So this is you will be familiar with this. So in the traditional deployment, you have directly deploy up to the OS, right? And then this application, some application greedy and use all the resources. You got some application die of starvation. In order to give them boundary, you go through the hypervisor VM, right? Nowadays you do VM version or container version. So this is VM. So VM, you have to package the OS, not resource friendly. And now the trend is container deployment. How many of you are doing VM? Okay, still quite few. Container? Okay, one. Is the kind of, if you go to the cloud, so this is the way to go forward. So it's a container deployment. So it's basically for the container deployment, so it's this is solve the problem. It works on my machine. This is often back to 10 years ago, you know, you have a tester, you have a developer, like a tester say, oh, it doesn't work. You say, it works on my machine, right? That's often the thing. Once you do container, it's no longer the case. If it runs in the container, it runs everywhere. So that's build once, run everywhere. So for container, you either use Docker or Podman. Do you know anyone know Docker? Docker. So most of you, right? And however, you all heard of that is a kind of Docker last year trying to charge people, right? Have you heard? So basically it's no longer free. And then is came up with Podman. And then Docker realized that mistake. Now is the Docker is saying, oh, okay, you can use it. And then I think the Podman currently is really, really popular. Any of you use Podman? No? If you haven't, check it out. Podman is run even faster. It's developed really fast. Podman is but it's pretty much similar. When you do a Docker build, Docker run, all you need to do is just Podman build, Podman run. So all your knowledge about Docker is applicable to Podman. And then you go to a Docker desktop. Do you use Docker desktop? Yeah, you use. Yeah. Also, you can download a Docker desktop, and then it has Kubernetes integrated. It's quite good. And also Podman also got a Podman desktop. Okay, Now you have container, right? You have a container, and then you need to you need to deploy that container to the cloud, and you need to manage the container, and you need the infrastructure to start a container and monitor the container. So this come with Kubernetes. Any of you know Kubernetes? At least you will have heard of it, right? Kubernetes do service discovery and load balancing. So it can find your service. If you got a request that comes through, Kubernetes can route to the backend for you. And also it does storage orchestration, and also it do automated rollout. So basically, when you do, earlier I said the CI/CD, right? You directly do a new deployment of your version of the application. And Kubernetes is very smart. It will route some traffic to the new version. If it works, it will get directly gradually route the rest to the new pod and gradually destroy the old pod. If it doesn't work, it will roll back. And also self-healing. Kubernetes, if you find one pod, basically the container, if it's not working, it will kill it and then recycle it, start a new one. And also it has Kubernetes got the storage, you can put your secret password and etc. in the Kubernetes secret, and also some configuration like username and etc. in the Kubernetes configuration. Okay, so back to now, you are in the cloud. So basically you need your cloud native application, use your favorite language, may it be Java. So if you don't use Java, try to learn Java. If you use other language, obviously you can deploy to the cloud. And then you containerize it and deploy to the cloud. Obviously, you have to know about deployment. Maybe it's kind of that's YAML file. Actually, it's on the way here. I'm thinking, how many of you like a YAML? Have you all heard about YAML? And anybody love YAML? Oh, you love YAML. That's great. Which bit of YAML do you like the best?
Well, I use it a lot for CloudFormation templates and stuff like that for AWS. It's just very clean. Just big fan.
Yeah, great. So YAML is like a mommy. You either love it or hate it. I was thinking, in the future, maybe ChatGPT can do the YAML file for you. Yeah, ChatGPT, create my deployment YAML file for me. Okay, so it's actually you are pretty much sorted into the cloud, basically containerized it and etc. However, sorry, what's your name again? Sorry.
Darling.
Darling. As Darling said, technology evolved all the time. It's not directly stop there, right? We have to keep on learning. And we just sit down and say, oh, okay, I reached to the cloud. And the next thing is wake up is serverless. You need to into the serverless. Serverless actually is what is a serverless? Let's first look at the evolution of the serverless. So basically, you do infrastructure as a service. So you manage OS, and then you come a container as a service, you manage container, and then platform as a service, manage application, and then function as a service is a part of the application running as a function. And then the question is, you can still see the runtime there, right? You can still see the runtime. So serverless doesn't mean there's no servers. Serverless has a server. Why is it called a serverless? Serverless just hide the server. Basically, you do not need to worry about server. So that's why it's called serverless. Serverless actually is if you do a hybrid cloud, the private cloud is not a target for your servlet. Serverless is basically pay-as-you-go pattern. You just buy the resources you need. So you really need to be fast, right? Really need the resources you need. So it's basically this is pretty much pay-as-you-go, renting. And the function you need to deploy as a service is not running all the time. If it needs to be up all the time, you don't save any money with the service. Service is that okay? One day I only use 1 hour, right? And then the rest of the time I don't need to pay the bill. If you need to run it 24 hours, you had better use your own resources. You will have a bigger bill. So this service, one thing is must be is fast. And also, if it's not using it, it should not occupy any resources. It should have ability to scale to 0. So I want to list the 2 things: function as a service and container as a service. So I'm not going directly to look at the function as a service. However, container as a service, you manage a container and you will have a very high flexibility. You do not need to directly tie with the cloud. A lot of cloud has a service capabilities. So you can do the function as a service. However, you will tie it by the cloud provider. If you do Amazon Lambda, your service, do you think you can run that service function in Azure? The directly is not compatible. So one thing I want to focus to look at the container as a service. So this is the cloud provider for service. So it's a function as a service. You can do Azure functions, Amazon Lambda, Google Cloud Functions, IBM cloud functions. However, if you do the function as a service, actually earlier outside I had a chat with you. What's your name?
Nick.
Nick. We had a chat with Nick. Actually, only the IBM cloud code engine, cloud function, can do the scale back to 0. All the other cloud, they at most scale to 1. They have a background a function running all the time. Also, it doesn't cost you much. However, it's not a true scale back to 0. And for the container as a service, you have Amazon ECS with AWS Fargate and Azure container. This one have Google Cloud Run and IBM Cloud Code Engine. So this is the kind of there's some functionalities and also capabilities offered by the cloud. Who using Amazon right now? Amazon Cloud. Okay, good. Azure Cloud. Okay, not many. Google. Okay, 1. IBM Cloud. I don't see any. I want to encourage you to look at the IBM Cloud Code Engine. Yeah, that's a new thing. So, and then is kind of, we mentioned the serverless. Is the cloud native application become irrelevant when it comes to serverless? So this is the new things we trying to IBM and also the open source community. We are trying to tackle the serverless kind of the area. Obviously, serverless you need to be really fast. The things are really fast. We need to have a fast startup. We do Java, right? Java, you have a JVM. The first, before you do anything, you need to start your JVM first, and then your application, right? So it's it's in the past few years, Oracle is trying to do the GraalVM. Have you all heard of GraalVM? Okay, So that's the kind of build time compilation. It's trying to do like a hard wiring, trying to remove some code, dead code, etc., and then compile to the machine code. You know, once it's compiled to machine code, you can start fast. However, because it's no GVM trying to start when you start your application. So this the Grow VM is no GVM anymore, because a lot of instrumentation tools in the past you're using no longer relevant. You cannot, because everything is sealed, you cannot inspect anything. If something goes wrong, you are on your own. So this is why it's kind of not many people use in production. It almost like you put the boat in the ocean without a lifeboat. So it's if you're courageous, yeah, go with it. So it's and then there's a new technology like trying to tackle the issue. How can we improve the startup time and still use the traditional GVM? So recently, in the Linux Foundation is a new technology called CRIU. It's called checkpoint restore in user space, CRIU. So the kind of the theory is you take if something started up, you take a snapshot. And then obviously, if you have a lot like a pod running, and if one basically your service started, you take a snapshot. And then if you create a multiple ones, if you need 5 more, you use that image directly basically ghost into that pod. So in this case, you no longer need to have a cold start. It's a warm start all the time. So IBM also has a Java. It's called IBM Sumaru. IBM Sumaru. It's built on the open source OpenJ9. Any of you know OpenJ9? No? So check it out. It's under Eclipse Foundation, OpenJ9. And then it's OpenJ9 has a CRIU, basically use the CRIU, implement the CRIU technology called Instant On. And also Open Liberty directly collaborate with OpenJ9. And also it has a feature called Instant On. With that, your Java application can start, the REST application can start within 100 milliseconds, really, really fast. This, for this one, is directly suitable. You can do the container like as a service. It's really easy all the time, even though you need 100 of the instances. That's like the first one, when you create a container, and then it's create basically it's do a checkpoint. All the others is all use the same image and can be created. So it's there's no code start anymore. So it's basically you can do the service and without any cloud vendor lock-in. So this is what I said earlier. You can do use the REST. So basically can do easy lift and shift because you do not use the AWS or Google or some other cloud like libraries. You directly use the like public APIs, and you can just also can utilize the fast startup. And if you do REST, you can collaborate with some other applications, and also because of REST, you can scale up and scale down without any problem. And then the big bit is no cloud provider lock-in. So it's this is the kind of when you enter in the cloud, you also need to make sure you are not locked in by any particular cloud. It's this is the kind of the one like the future. You do not need to log on to any other particular runtime, any other particular company, and you should be free to move around. So this is the best like a programming model and best architecture you can do for the service. So the answer to is cloud native application is obsolete. The answer is no. I think that's what summarized today. So if you have the monolith, it's not evil. If you have problem, you solve the problem. Maybe if you want to scale part of the monolith, you might need to chop that part out to make it microservices. And the other thing is if you enter into serverless and you think, make sure you do not want to lock down by any particular cloud. And think about container as a service and shop around. Look at the open source technologies you can use, like microprofile, Jakarta, EE, Open Liberty, and etc. All the open source. So this is useful resources. I wrote also rethinking microservice in medium.com. And this is a microprofile IO. Check out microprofile, Jakarta, EE, Open Liberty, and also some other like a model to macro I mentioned earlier about how to chop monoliths into microservices. Actually, I also published a book in 2020 about practical cloud native Java development with microprofile. It's on Amazon. That's the kind of QR code. If you are interested, and get a copy of it. I think that's concluded today's talk. Yeah, are there any questions? A lot of information to take in, right? Yeah.
I think one of the biggest problems that we're seeing in terms of moving from a monolithic approach to a microservices approach, particularly when we're dealing with cloud platforms, is predicting and controlling costs.
Yes.
Because the costs are somewhat opaque, to a certain extent until you have experience of them. Whereas we know what a server costs, we know what our network infrastructure costs. But going to a scalable cloud-based solution, although it may be scalable, and we don't have the cost of scaling, still understanding what those costs are going to be is quite difficult to get to get your head around. None of the cloud providers that I've experienced so far, which is fairly limited, I haven't experienced the IBM ones, seem to be particularly good at sort of account management and all of those other things which you kind of look for in a service provider, and they just sort of expect you to sign up and pay your bill. So having I don't know whether IBM's approach is different. We haven't looked at IBM. I suppose the view of IBM is very much that it's much more of a large corporate provider rather than for sort of SMEs or medium-sized firms. But maybe you can correct me on that.
Yes, so that's a good question. I think for the cost, it's for the serverless, you can see the cost, because that's pretty much pay as you go. You will get a billing to see how much you used. For other cloud cost, because you cannot do the subscription, right? You're right. I'm not 100% about the billing system about IBM Cloud either. So it's I can find out. Yeah. Certainly that is the issue. It's basically kind of it will be nice if it's this cloud provider is charge you, okay, you have one instance running for this long, and this is it's pretty much similar to the mobile phone, like a contract, right? Contract base is no matter whether you use it or not, and this is your monthly bill. But if you do pay as you go, each call you make, you will get this. So this is why, this is one of the reasons smaller, very smaller firm go with the serverless. Because you can see from account, accounting can see that cost clearly. Yeah. Yeah, good question. Are there any other questions?
David, anything online?
No.
No.
What are the, yeah.
I remember your name now.
Yeah, I was just wondering, what are the main benefits of the IBM cloud functions over like AWS Lambda functions or Google Cloud functions? What are like the main benefits?
Yeah, basically it's there's another thing. I forgot to mention. So it's in the cloud, AWS is the only cloud that do not support a cloud event. All the other cloud support the open source. Basically, you send basically if you do a service, you just do in the form of cloud event, and then you use the cloud event. Basically, you don't do the vendor lock-in. For the IBM cloud function, it's quite new. And I mentioned earlier, you can scale back to 0 with the cloud event. So the other thing is build on kind of the like cloud event. It has a first class citizens. It's so easy to get started. Also, we have a blog on the openliberty.io. Let me see. If you have not seen this, so this is the openliberty.io. It's we talk about service. So here, if you want to learn about like how easy to get started, here is the blog. Is basically it's so easy. You don't need to do much if you know REST already. So there's a directly app. You can directly try it out. So use a cloud event with the vendor login, and also the setup is quite easy with the cloud code engine as well. And you can real scale to 0, it will tell you. Yeah. Good question.
We have a question online from Daniel.
Yeah.
It's a little bit long. He says, I would expect that most monolithic applications would usually have a single point of entry and authorization. When breaking an application down into microservices, how do you weigh up running multiple public services against all private services between a single endpoint?
Yeah, this is a really good question. So it's in my slides. So here, so this is a Microservice DWT. You all heard of the OAuth or OpenID Connect, right? So it's basically the implementation to use token, JSON web token, GWT. So in microservices, so basically how can you authorize the request to access the backend? So that is like a monolith, actually, yeah, you log on and etc. is all being dealt with internally. For this one, the only way to pass pass through the token and etc. is via the REST. So basically, if you call microservice B and then B call C, the only way you can pass on the authorization and etc. is via the HTTP header. So what it did is in the JSON web token, in microprofile GWT, basically is add a couple 2 claims. One is your user information. The other one is which group you belong to. So basically across the line, if it's a kind of, I pass on to you, you pass on to her. So it's basically is I tell you, I'm Emily, I can access like this backend, you say, okay, yeah, the Emily, and so when you get this the header, so you can review to say, oh, okay, I allow Emily to access my service. So this is how it been dealt with.
Thank you.
Thanks. With that, I think I'll pass over to you to conclude this
Thank you.
talk.
Thank you. Well, I won't pretend I understood most of that. I hope you did. But what is for sure, Emily is in this field and has given us a lot of information for us to check out, look further, and to develop our skills in this area. I'm sure you will have lots of questions later. Either share them amongst yourselves or field them to us, and we'll try and pass them to Emily in the future. Certainly the slides carry a wealth of references and so on. So when we've got those from you, Emily,
Yeah.
and also the video, which David will wrap up and put on our website in the next week or so, hopefully, please look through and see what more nuggets you can gain from that. Meanwhile, please join me in thanking Emily.